This is an 555 timer, and let's see how it works as astable mode.
Alright, so now let's see how it works as stable mode. So here what I'm going to be doing is, for stable mode I will interconnect the pin 6 and pin 2, which is the threshold and trigger pin, and I will connect a capacitor to it, and this is given to the ground. So here what happens is, the capacitor I will give it of around some 100 microfarad. Here what happens is, when we give the VCC and know that the capacitor output gets charging and discharging. So here what happens is, when the capacitor output is 1/3 VCC, so suppose this is full 1 VCC, the VCC is 1. So if the capacitor output is 1/3 of VCC, then the trigger output comes high, comparator gets high, and it resets the flip-flop. So when this resets the flip-flops, the Q bar gets high and the Q is low, and as it is not get here, the output will be high, which is binary 1. And when the VCC is more than 1/3 VCC and it is less than 2/3 VCC, then the threshold comparator gets on and it sets the flip-flop again, and the Q bar output gets low and Q gets high, and it will again, as there is not get, it will give a binary 0. So here, due to the discharge and charge of the capacitor, when the capacitor goes high and the capacitor goes low, so due to the movement of 2/3 charge and 1/3 charge, the comparator keeps on off on alternatively. So it sets and resets the flip-flop alternatively, and it gives the output binary 1 and 0 at whatever frequency we want, without any external input signal. And also for astable mode, this was the internal diagram and how it works, how the astable mode works when we operate the 555 timer in astable mode. Now also for to see the output, here I will add an 1K resistor to an LED so that I can see the output. And also I will add another 2 1K resistors between the pin number 8 and 7, and another resistor between the pin 6. Which would be also 1K. So that it can take these resistors as its voltage divider circuit, and it can also, by the action of charging and discharging of the capacitor, it can produce the output. Here also we can add a potentiometer if we want variable frequency, so that the voltage gets divided according to us. And also this is the reset pin, which is the pin number 4. So if the pin number 4 goes low, then it will reset the flip-flop and the timer begins to generate the frequency from starting. Alright, so right now I have written again the diagram of it, and I have connected the 1K and 100 microfarad capacitor, which you can see right here, 100 microfarad capacitor and 2 1K ohm resistors. So here the pin number 4 and 8 are connected to the VCC, which you can see right here, and here the 1K ohm and another 1K ohm is connected between the pin number VCC to pin number 7 and 7 to 6, which you can see right here, these both. And the pin number 6 and 2 are interconnected, which you can see right here, and the 100 microfarad capacitor is connected from ground to this here, which you can see here. And right now, as you can see, the pin number 3 is connected to this LED so that I can see the output. So here we get the output like this, which are the square wave pulses, which is the binary ones and zeros. So right now the frequency is around some words maybe, yeah, but it can go up to some more kilohertz. As if we try to change the capacitor value, if we decrease the capacitor value so that the charging and discharging happens fast, and even if we change the resistors value so that the on time and off time can be variable. So that's all for now. Thank you.